This conference will now be recorded.
Hello, everyone. This is Don Milstein, president of Vitrek. Welcome to our webinar on our new electronic DCLoad. We'll get going in a minute or so. We got a few more people joining on, as we can see. Excited to be presenting this presentation. We'll be joined by Chad Clark, our vice president of sales, which we'll introduce in a minute or so. So give us another minute and we will get going. Thank you very much. Okay, welcome again. As I said, my name is Don Milstein. I'm president of Vitrek, and we'll be presenting today along with Chad Clark, our vice president of sales, our webinar on our new DL series, the electronic DCLoad. And hopefully everyone is ready for a good 40-minute presentation. Go ahead to the next slide here. Like I said, here's our contact information. I'll kind of kick it off, and then Chad will come in with the Vitrek side. Chad, why don't you say hello to everyone?
Hello, everyone. Thanks for tuning in today. Appreciate spending a little bit of time with us this morning here on the West Coast.
All right, great. You'll be in good hands. Chad has well over 10 plus years experience with Vitrek, knows the products inside and out, so it should be a good session. As we go, we want to kind of, keep your phones on mute. It's helpful, but we will have these points throughout the presentation where we'll stop here for questions. You can, at all times, please use the chat feature, ask questions. We have people monitoring that. They'll answer it, and then we'll recap. But when we do get to these sections, if you do have a burning question, we'll unmute the phones and feel free to ask if you'd rather do that than through chat. So we'll have good opportunities throughout the presentation for that. So just want to kind of give you a quick introduction. Vitrek's been around over 30 years, truly one of the leaders in high voltage test and measurement, especially known for our high pot testers and some of our other products. We're headquartered in San Diego, California. Everything's done there. Manufacturing, engineering, customer service, sales, marketing, everything is done out of that office. We're truly an American-made product. We do assembly there and then bring it in, test, calibration, and out the door. But we do view the world as our market. We have over 30 reps and distributors on the ground in 30 different countries. So we're truly an international company, which means we not only manufacture internationally for customers and ship it to them, but we're always looking at standards throughout the world and making sure we can help our customers comply with standards they have and make sure our meters and devices all meet that. When you look at our product lines, we'll go through this in a little bit more depth, but high pod electrical testers, cable test systems is another feature there. Our power analyzer series of products and high voltage meters, and the loads, which we'll talk about today. And our actual facility itself has ISO 17025 accreditation for calibration. So every product goes out as calibrated, gets a certificate, and at any time, obviously, if you want to renew your calibration, send it back a year later, we can provide that service, or you can go to your local calibration labs. And to the next slide.
Yep.
All right, thank you. So industries we serve, and we'll kind of touch on some of these as we go through the presentation today. Really kind of covers the whole market, right? Semiconductors and medical devices are big areas, aero and defense. Electrical equipment manufacturers, people making electrical, circuit breakers and panels and that kind of thing. So we really covered a full gamut. The one thing I'm proud of during this crazy time and for COVID, we got the call from the state of California, said, oh, everybody's shutting down, and we did the same thing. But within a week we had to open up, and we're proud to say that our customers said during critical infrastructure industries like the medical or aerospace or whatever, and we had to bring our projects back online and bring our manufacturing online, and all of our employees stepped in and did that. So we've been fully operational this entire time, proper spacing and health, but had people working from home where they were able to, but our production people have been in there and really done a great job. So with that, we'll go ahead to the next slide. When you think about our customers, we fall in a couple major categories. Consumer products, whether it's a refrigerator from Sub-Zero, a toaster from GE, or computers and printers. It's a major area that we work in. On the commercial side, I had mentioned, kind of the electrical manufacturers, Siemens and Eaton. Healthcare companies like Philips for a lot of their products, and Abbott Labs, and then the aerospace and on and on. I'd say over the last 10 years, we've seen a big increase in green and sustainable type products, whether it's electric vehicles and cables for Tesla, or transition from fluorescent to LED lighting. Companies like Cree and others need products for testing. The whole photovoltaic and solar alternative energies is a big marketplace. And we also play a lot in the lab space. And when I talk about lab and calibration laboratories, we're talking about the big national labs like UL, TUV, CSA, some of your national labs, whether it's Lawrence Livermore or the U.S. Air Force, and then all the calibration labs throughout the world, we're supplying products to them. That's another big area for us. To the next slide. So when we think about our products, I just show you this so you understand how we have the expertise to be in the DCLoad market. We have 30 years experience in doing high pod testers for electrical safety tests and making sure no one's getting shocked. Every time a refrigerator comes down the line, it's getting plugged into the high pod tester and gives a go, no go kind of thing. On the power analyzer side, one of the highest quality power analyzers on the market for the money. Varies, on the speed, the accuracy side, really testing that power efficiency both in the lab as well as on a production floor. A high voltage meter is without a doubt industry leading, second to none. We have a lot of countries that use this high voltage meter as their base device for calibration in their labs and throughout those countries. And our new product is the DCLoad, which Chad will go into more depth on this webinar. So with that, just quick stop, like we said, see if anybody's got any questions, and we'll go ahead and turn it over to Chad, unless someone wants to jump in.
All right, you guys. Don, thanks for the intro there. We're going to get into kind of some of the meat here on our electronic load. If you guys have any questions at all, you can either save them for some of the break periods that are coming up, or just go ahead and throw them in the chat, and I'll try to answer those during a question and answer period, or maybe one of my associates will be able to jump on that and just type it in during this. So here we go. So what is a DC load? So basically what a DC load does is it sinks power in the way of being a highly variable resistor, and it's used to test anything that outputs, DC voltage, DC current. There's a variety of ways that it can actually, modes that it can actually be used, but at the end of the day, really what it is it's a highly variable, big power sink. What we do in other manufacturers of this also is you can set it up to run your power supply at a constant voltage, or if you want it to be in constant current, constant power, or constant resistance. As you guys know, with Ohm's law, if you change one variable, it's often going to change the other. And we also do not limit you guys to just one of these. We can set up an entire box, and it gives you an area that you can work within that in the current, voltage, and resistance areas. All right, so here's kind of a look at the front and rear panel of this. Some of the applications where people might use it are going to be obviously making power supplies. A lot of people don't manufacture their own power supplies, but they need to use a DC power supply within their unit. They're relatively, they can be relatively inexpensive, and it's kind of hard to quantify that performance. You want to know how reactive it's going to be, how fast, how linear, how much voltage drop you're going to get with load, things like that. And it can all be fine. You can be buying power supplies, and then one day you get a batch, and it just kind of starts affecting the other circuitry within your unit. So a lot of people are using our loads to kind of pre-qualify power supplies that would go in their products. LED drivers is the same thing. It's very important to have a driver that plays well with your LED. Of course, batteries, we have a couple different features that you can use to test batteries, but one of the big ones is just claimed capacities. You see all these 18650 lithium cells that claim, I don't know, 3,000 milliampere hours or more. Are they? And the funny thing is that ampere hour capacity is going to change based on the profile that you're loading that battery. So some things are going to really excel at low current for long periods of time, and there's other products or other batteries, I should say, that are going to do well at high currents for short periods of time. And that all needs to be quantified. So typically this product's going to range from 125 to 500 watts, and I'm talking continuous RMS here. It'll go far in excess of that for short periods of time, and we're really looking at up to 500 volts. That's kind of the arena. There's two different models. You're going to get a 150 volt version or a 500 volt version, depending on what you need. All right, so some of the key features here is it does have integrated meters, so you're going to be able to look at your exact power, current, resistance, and even more importantly, it does have a scope built in. We're going to touch on that a little bit later, but there's certainly times where people would be using your scope in parallel with a load. Like, let's say you want to see how much delay there is from the time that you load a power supply to it till it gets back to the minimum threshold voltage that you're asking for. Sometimes the easiest way to do that is to, with another DC load, just use a scope, and you can zoom back in and look at that later. Or with ours, you can put it in scope mode, and you can just look at the grid and easily count how many milliseconds it was to get back to that area. In addition to that, we do data log over a very, very long period of time, which a lot of people find useful. All right, so this is a scope view. This is kind of what I was talking about earlier. You can see here the resolution across the bottom, that's 400 microseconds total. And we're looking at 200 millivolts per division on the other axis. So you can see that exactly where the delay is, either in the load responding or in the power supply responding. And this is, a standard feature. It comes with every single product. And like I said, this is typically where someone would use an external scope, which would cost even more than the DCLoad itself. So real big value here, I think, getting the scope screen. And even if this isn't something that you're going to be using on a daily basis, being able to have this, zoom in, take a screenshot, and put that in your report, we feel it's very, very valuable. All right, so some of the applications, the big one's obviously going to be power supplies, LED drivers, which are power supplies, are just kind of specific. UPS systems, that's another big one. Everyone wants to know, how long will my UPS system keep this up and running? And you could actually you could program the arbitrary mode in the DCLoad to duplicate the load of the product that you want to be, powered by the UPS, and a very accurate amount of how much time that's going to run off your UPS until you hit that minimum voltage and it's going to shut off. Inverters, DC to DC converters, all kinds of the same thing. You're looking at, efficiency, and part of that is you need a load. And if you know the power that the load is sinking, it's half of your equation right there. Photovoltaics, obviously, those are produce DC, as well as batteries and fuel cells. So it's very broad. The whole key here is DC. So this is something we talked about before. If you wanted to do a simple battery test on capacity, you're going to set either a time limit or a voltage threshold limit. And basically, in addition to the loading, which will be done on a different screen, but you're basically going to be able to set it up, turn the load on, and come back to a amp hour or watt hour capacity of it based on the profile that you choose to load the product at. You're going to accumulate data. Everything is going to be stored there, and it's a nice built-in feature. All right, so here's kind of a how some of our customers are actually using the product. So here we have a photo of a very generic power tool, maybe from like Alibaba or something like that. But you have all these lithium-ion tools right now that are going to be brushed motors or brushless motors. And kind of what we were touching on earlier, the way that you use the tool is really going to impact the battery life of that. Are you just going to basically stall out that motor on a big drill or a big saw, or will it be used less frequently for a longer period of time? And this is where you can use our arbitrary mode to simulate that. So you could take that duty cycle and kind of replicate it best you can, and really give your feedback to the people that are making the batteries of the actual capacity when used in their product. And that's great. All right, so this is where we are a little bit different than the competition. So hopefully you guys can see my mouse here on the screen. This is kind of a typical load right here. It's going to be defined by the blue and purple line. So most of the products don't really do well below a volt or 0.8 of a volt or so. And then they're going to taper their maximum power as you get out higher in voltage. Where we are very strong is we're able to go to very, very low voltages, as you can see, approaching 0. And then we're also able to withstand short periods of time, and we do specify it over here. If you're looking at the maximum, this is 100 microseconds. So if you're only going to apply power for 100 microseconds, be that a surge or a spike, you can see that we're able to, handle currents all the way up here and at a maximum power level of 7.2 kilowatts out of a 250 watt load. So that's pretty special. In other situations, people would need that 7 kilowatt load just to do an instantaneous measurement way out here in right field. But we can do it. So there's no sense in buying all this extra RMS power if really what you're looking at is transients. And then as you decrease time, we approach closer and closer to the RMS value. So hope that makes sense to you guys. If you have any questions about it, let us know. So here's a look at the front panel and basically our GUI. So this is a 5-inch touch screen. And every single field on here is editable either by touching it and having a pop-up come up where you can select what you want and make your changes, or the adjustment dial. By rotating the dial, clicking it, you're going to go to your editable fields and make your changes. You can see that we also have the USB drive on the front. That's where you're going to be able to pull down your screenshots right to that, or store some test results. Loading indicator, you're going to see in 2 spots. We got a green light on the front, and also on the screen, you're going to see if the load is on or off. And for your convenience, we do have front panel terminals. You can see they're limited to 30 amps, which is going to be fine for most applications. But you'll see later, which you'll see here in 1 second, that we do have blades on the rear. So if you do want to go up to 60 amps or whatever your maximum requirement is, that's going to be the spot to do it. Along with the external voltage sense, Ethernet standard, USB standard, and you do have that digital I/O port. Should probably add that we are LXI compliant with this unit. It's something that we're looking to do and plan to do with all of our future products. Ethernet has really been our preferred interface since we released the 9.5X some time ago, and we just found it to be the way to go. So some of the features, I think one of the biggest ones is that we're rangeless. So there's no periods where we're not able to load or give you a measurement result because we are switching ranges and missing a small portion of data. Our accuracy is something that we do not only specify, that we actually we hold ourselves to it. Some of the other loads out there you will find they're specified very generally, and we were able to do some head-to-head comparisons and find some situations where the people are not necessarily complying with their specs. We've definitely tried to specify our product very realistically and stay within those specs. The 5-inch touchscreen talked about earlier. And here's also where we talk about the slew rates. So we're able to ramp at a rate of 8 amps per microsecond, which is fast, and it's really fast for a 250 watt product. You might see some of these bigger rack systems that are kilowatts. Yes, they can go much faster, but they also have more ground to cover. When you're only going to 250 or 500 watts, 8 amps is going to get you there pretty fast. You're at our max specifications in a few microseconds. All right, so we kind of talked about this before. With most loads, you're going to set it to constant current, constant voltage, or constant power. We don't limit you to any of those. If you wanted to define something as constant voltage and something else as constant power, you can switch back and oscillate in between those two limits, if you wanted to call it that. And this is kind of allows us to have an arbitrary mode that's as complicated as you want. You can really set up the parameters that you want for loading and figure out the response of your products. All right, so we're going on to some more of the features here. So we do have the battery test mode, which is going to let you define that ultimately ampere hour capacity or watt hour capacity, depending on how you want to look at it. And right here, the screenshot that we're showing you is actually from our web interface browser. So you're actually able to web into this thing, simply connect it anywhere on your network, enter the IP address of the product, and now you can use it exactly like you would from the front panel. This isn't a software option. This isn't anything extra that you buy. It just comes with every DL. You cannot actually rotate the knob because it's over the web, but you can click on it and it will, operate the same way it would if you were rotating it. There's so many opportunities for this. It's whether you need someone to remotely go in and double check your settings, or let's say that you have this operating offsite and you simply want to read the screen, or you want to use some simple video capture software on your computer screen to see what the load's doing for your report. So many different ways that you guys will like that feature. So we talked about the wide voltage and current capability. You saw back on that graph, we're able to go well below 1 volt, approaching 0 volts, and up to 84 amps when using those blades. You guys will be a little challenged to find other loads that are actually made here, and I think more importantly, supported here in the United States. If you call us here at the factory, you're going to be able to talk to someone that was either involved in designing the product or building it, testing it, working on the firmware directly. You don't have that 1 to 2 day delay of, let me get in touch with someone at the factory, then they translate it, and then they talk to you. You can actually talk to a real person, maybe even in your same time zone, and get the answers to your specific questions, your specific applications figured out. There's our interface options. It's really going to be the Ethernet, USB, and then the DIO. I know that was kind of a long run here, but does anyone have any questions? If you do, go ahead and unmute yourself and let it rip.
So Chad, this is Don. We do have one question from Ian about application notes. We have some on the website, and in particular is asking for battery-powered automotive customers, bus manufacturer, transit authorities. Currently, we don't have that, but Ian and anyone, if you email Chad and our team, we have experience in every one of these industries and can talk about your specifics. I know we've done a lot of work with, the automotive industry and with transit authorities in particular just recently. So feel free to do that. Go ahead, Chad.
Yeah, obviously, Ian, we can talk after this. Ian and I have worked together for at least my whole 13 years here at Vitrex. So I'll get back in touch with you and we'll see what we can come up with. And if it's not an app note that we have right now, we can definitely get it in the pipe and create that. I'm sure if it's something that Ian wants to see, there's other people out there that want to see it also.
Yeah, but just in general, our sales engineers can talk about those specific projects and help someone for any of these industries.
Without a doubt.
Why don't you go ahead and to the next section.
Let's keep going here.
I actually do have a question. This is Gene Stidham from Stanley Black & Decker. I've been using one of the 500 watt loads for a couple of months now. It's a loaner, which thank you very much for loaning it to me. I'm testing power cells as opposed to energy cells. And I've noticed that I'm able to push the load a little higher than its rating for I would say a sustained amount of time. Say you've had a 20 volt battery and you did it 30 amps. Instantly the voltage drops a little bit to somewhere around 17.6, but it'll still maintain 30 amps. So you're looking at like 530, 540 watts. And I've noticed that it'll actually do it. I'm afraid of damaging the unit.
Yeah, so
I can jump in
and
here
this
too,
might be a better question for engineering. Is that you, Brian?
Yep. So We actually developed those limitations on the unit with quite a bit of margin, and we definitely allow for use slightly above. The unit's going to let you know if anything is going to occur, if overheating is going to occur, something like that. There's a lot of protections in the unit to help prevent those types of issues from occurring. So you can definitely keep using it at those levels and you should have no problem there. If it ever does issue you any warnings, then certainly you should look into disabling it for a short time and try retesting.
Okay, thank you.
And Brian, correct me if I'm wrong, but won't ambient temperature come into play here also?
It's totally correct. So, if you're testing in a high heat environment, then obviously there's going to be less headroom as far as heating internal to the unit. So you'll reach that high temperature warning a little bit sooner in a high heat environment.
We've specified the unit to work over a broader temperature range. So if you're at the bottom end of that temperature range, there's definitely going to be more headroom than if you're at 40C or whatever we spec it at.
Good. We keep it nice and cold where it's running, so that's good.
Yeah, ice her down. But
Gene,
yeah, if you have any
Pat
questions.
Baldwin here. How you doing? Hope you are well. I just wanted to say, you break it, you buy
it.
Thanks, Pat.
Yeah, but it's a demo unit. You forgot that part. It's not his yet. All right. Are there any other questions? All right, we're gonna move on. We're gonna get through some screenshots here, and we'll try to get through these fairly quickly. So what you're gonna see there on the left is basically our kind of standard numeric screen. For a lot of people, this is going to be the most common screen. You're looking at your channel A, channel B, voltage, current, the resistance of the load, things like that. And that's all going to be within the black box. And then everything in the purple, if you want lavender, if you wanted to call it that, section is going to be either editable fields or just information related to your interfaces, time, date, things like that. So here we're looking at a signal here in the scope mode. It's not really zoomed in this case, but you are able to see, the switching from channel A to channel B and the loading associated with that and the two different limits. We have the sweep function here that's shown, and also the history mode. And the history mode is where we're actually able to, look at years of data and auto compresses, and you can go back in. You can either export that data or you can zoom in to a pretty high level and actually see any events that happened during that whole time that you were loading the unit and logging all of that data. All right, so this is kind of the setup screen here on the left. You're going to go in and you're going to be able to set your voltages, your maximum currents, things like that, the time associated with it. And here you would be looking at a test that's going to take you from 4 amps of loading to 3 amps of loading, 3-second back and forth, pretty standard. And then you can look at all of our different loading modes right here. So we can go from, almost no load to maximum load, sweeping, arbitrary mode, table, or basic. So really all of your options are there. And once you select one of those, you're going to be able to run in that mode. So data logging, it's one of the, go ahead, someone have a question? So when we're data logging here are your options. You can download it to a CSV as selected here. Synchronous data, it's going to have the timestamp on there, and then you just start your log and it's just going to keep running until you end that. The select data is going to go through and let you select the data points that you want in that log. And then you see our system info screen, where you're going to easily be able to find your serial number, firmware versions, MAC address. It's all there, including how much memory is available on your SD card. Easy way to look at the IP address also. If you want to go in and use that web app, there you go. Just enter that in your browser, assuming you're on the same network. All right. So when you're looking at the USB export settings, here's everything right here that you want to export. Whether you want system settings, scope capture in your charts. The self-test of the unit is quite thorough, and there's not very many situations where the unit would be able to pass self-test and not operate properly, and most likely within its specified, within specification. So some of the advantages, and this is kind of just recapping the features, it's really going to be high accuracy. If you want to have a load where you can trust the accuracy on the screen and not have to verify that with something else, whether it's another piece of equipment, a DMM, a parallel, a scope, or whatnot. With the DL, I hope that you guys would have that confidence to actually trust our specs. We spent a long time testing this product, and we really stand behind our specs. And then it's also that wide range of power capability. Going back to that graph on page 17, you can see if you looked at the surface area where we're able to operate in power, it's so much broader. I understand it's not continuous above 500 watts in a lot of those situations, but so many people only need that peak result. They don't need continuous 3 kV. I'm sorry, 3,000 watts. And then the scope function. And for most of you guys, this will completely eliminate the need to have an additional, real scope. We're going to be fast enough, responsive enough for most of these DC applications. All right, so ordering information. You can see that we've broken it up into a couple different versions. So you can have either lower voltage and high power, or both. So it goes anywhere from 150 volts, 125 watts, up to the 500 volt, 500 watt versions. We spec'd it out as far as the peak power, maximum current. It's all right there. We don't hide behind our prices. These are very competitive. Even when you're comparing them to some of the offshore manufactured products, I really feel like we're right there price-wise. And we're very proud of this product, and we're kind of re-releasing it. We chose a pretty poor time to come out with this right before this whole coronavirus thing hit. So we're putting some extra effort into it right now to promote this product again. If anyone has any requests for a demo unit or a virtual demo at this time, please reach out to us and we can support you. Does anyone have any questions before we wrap this thing up?
This is Gene Stidham from Stanley Black & Decker again. I do have one additional question. It has to do with controlling this remotely via LabVIEW. It's one of the things that we do all the time with all of our equipment that we currently have. And that's one thing we would love to do with this unit if possible. Is that a possibility?
Yeah, so there is a full Skippy command set available. So standard ASCII communications through either that USB or the Ethernet. Okay. The USB is going to be a virtual COM port, so it might be a little bit easier through your LabVIEW, but you can certainly do Ethernet socket openings through LabVIEW as well.
Okay, cool, thanks.
Hey, well, Chad. That includes it. Yeah, that concludes everything.
Chad, I have
you guys for tuning in. Go ahead.
Can you go back to slide 17?
Yes, I can. Let me see if I can.
You know, I like that graph. One thing I wanted to point out is the y-axis on that is logarithmic. And if you look at that purple curve, you see that 250 watt curve, and then you see the red curve and it's 7.2 kilowatts. Well, because that's a logarithmic axis, it's really downplaying the fact that there's a huge difference between those curves. So, you know, on that graph, 250 watts doesn't look much different from 7.2 kilowatts, but 7.2 kilowatts is a lot bigger.
It is. Yes, and I didn't point that out. Thank you for reminding us. And it goes the other way also. You know, a volt and a half is much higher than microvolts over here.
Right. You know, I get a lot of customers who ask, do you have something that can run below 1 volt? Because no one has anything like that out there. This thing can go down to 0 volts. So it does have an internal resistance. And if you pass a lot of current through it, it will develop its own voltage. But especially for lower currents, we can go way low. And that's useful for testing things like semiconductors that other people can't test.
Good point.
All right, any other questions or comments? And Chad, just go to the last screen so it has your contact information. This presentation will be sent to everyone after this conference, and will also be on our website in a taped recording. So at any time, feel free to go back or refer to your colleagues if they want to see the information. And if no other questions, we'll give it another minute. If not, appreciate your time, and hopefully everyone gears up for a safe weekend here.
Certainly.
Thanks, guys. Very informative.
All right. Thanks, everyone. Talk to you soon.